All right, so in this video, we're going to talk about angles not necessarily on the chorded axes, not necessarily only in quadrant one either. So we'll take a look at reference angles. Reference angles are positive acute angles formed by the terminal side and the x-axis. Okay, so in the first example, we'll take a look here at sine of 7 pi over 6. So the first thing that I would do is I would go ahead and get the xy plane on your paper. 7 pi over 6 is going to be down here in quadrant 3. So this guy right here, that whole thing is 7 pi over 6. Now, to create a reference angle, again, it's a positive acute angle formed by the terminal side and the x-axis. So this is actually going to be the reference angle. So the reference angle looks to be a pi over 6. Now, from here, we can go ahead and drop our perpendicular. Remember, it's got to be attached to the x-axis, and that gives us now our triangle. If we label things just like we did in the last section, then what we're going to have would be a 1, a 2, and a square root of 3. However, this point right here that we would map to, we would need a negative root 3 to move left and a negative 1 to move down. So now that we're no longer in quadrant 1, getting to those points, we have to remember how the xy rectangular coordinate system works. We would need a negative root 3 to move over and a negative 1 to move down. Now we also remember that sine is the ratio of y over r, so the y value is the negative 1, the r value is the 2, which means that sine of 7 pi over 6 would be a negative 1/2. All right, the next example would be a cosine of negative 4 pi over 3. So we'll start the same way. I'll go ahead and put the xy plane on the paper. Negative, remember negative just means we're moving clockwise now. 4 pi over 3 puts us up into this quadrant. So that angle right there, that's our negative 4 pi over 3. And the reference angle would be right here, terminal side and the x-axis. So that looks like a reference angle of pi over 3. If I go ahead now and drop my perpendicular, I'll go ahead and label. We're going to have a square root of 3, a 2, and a 1. But once again, remembering that we're not necessarily in quadrant 1 anymore, we would need a negative 1 to get over into quadrant 2 and a positive root 3. The hypotenuse is considered a distance always being positive, so the hypotenuse will always be positive. It's always going to be the x's and y's that track us to this point, so we have to consider them. So cosine is the ratio of x over r. Here's our x, here's our r. So we have now cosine of negative 4 pi over 3 is going to be negative 1/2. All right, so now we're ready to talk about the fundamental identity. But before we can do that, we need to talk about the unit circle again. And if you remember, the unit circle was x squared plus y squared equals 1. That was a circle centered at 0, 0 with a radius of 1. We also talked that if we went ahead and constructed an angle here, let's say theta, that the ordered pair would now be cosine theta, sine theta, where the x-coordinate was cosine and the y-coordinate was sine. And that's exactly the substitution we're going to make. We know that this is the x-coordinate. We know that this is a y-coordinate. I'm going to take both of those, and I'm going to come back into the equation for the unit circle. When I do this, I get cosine squared theta plus sine squared theta equals 1. And that's the fundamental identity. Now, we'll use the fundamental identity quite a bit in future sections, but for right now, we'll go ahead and take a look at an example. All right, so the example we'll look at here is to find sine of theta given cosine of theta is 2/5 and tangent is negative. It does say specifically to use the fundamental identity, so we need to make sure to do that. So cosine squared plus sine squared equals 1. And the first part's really not that complicated. We know that cosine of theta equals 2/5, so I'm going to plug that in for cosine. So I'm going to have 2/5 squared plus sine squared theta equals 1. So that's going to say that sine squared theta equals 1 minus 4 over 25. And sine squared theta equals 21 over 25. Now, when we square root both sides to get sine all by itself, we have to remember that if we put the square root there, we have to remember to put the plus or minus there as well. So sine of theta equals plus or minus the square root of 21 over 5. However, we need to make sure we give the correct sine of theta, and to understand if it's going to be positive or negative, we need to come back and we need to look at tangent. It does say tangent has to be negative. So we know that from the given information, cosine of theta is positive and tangent of theta is negative. So to figure out if sine is positive or negative, we need to find the quadrant where cosine is positive and tangent is negative. So to figure this out, it's just a matter of understanding that cosine is the x over r and tangent is the y over x. Those x's and y's, those are all coordinates for ordered pairs. So that tells you which quadrants you're going to be in based upon them being positive or negative. So for cosine to be positive, that means our x has to be positive. And for tangent to be negative, that means the x and the y have to be opposite signs. So that puts us down here in quadrant 4. Okay, now if you're having a hard time seeing that, I'd recommend putting together some possible ordered pairs with x's and y's and understanding the relationship of their ratios from above. So since we're in quadrant 4, sine is going to be negative in quadrant 4. So our final answer now, sine of theta, would be negative square root of 21 over 5. Now, from experience, seeing all of this information with quadrants and positives and negatives and then coming down into here and having to draw a conclusion is something that's a little difficult for students to see the first few times. So it's very important to understand which trig functions are positive and negative in which quadrants. I'll leave you with that, and I hope you take a little bit of extra time at the end of this lesson to go back and think about which quadrants all of the trig functions will be positive and negative in.